Hi, my name is Michael Garcia, and this is my reinforcement learning project from my AI class CSC 270. I started out with the program that we created in class with main.py or GUI underscore main.py, which are native Python interface programs. And then from there, I looked for other more well-rounded user interface programs, and I found Streamlit to be quite capable, so I went with that. As the project grew, my original Streamlit application uh, went over 1,000 lines. When that happens, I tend to start looking at ways to break up the code base so that I can more easily read it and uh, customize it. So if you look at the structure of the repository, I have docs. This has dev notes. These are engineering decisions that I recorded for myself to come back to in the future so I'd understand the decisions that I made and how the code functions from a building standpoint. I also wanted to create some documentation for users who are not me, so I created this for beginners documentation, which goes over some of the basic Python elements that I used in this uh, application. I also created a logger for the logging that I did for testing, Markov decision process documentation for reinforcement learning algorithms, math foundations documentation because I used fractal algorithmic edge cases using the Mandelbrot set and Julia sets. Phase one here is basically my roadmap that I used to create this original uh, application for the class. And then phase two is where I'd like to take it in the future for unmanned ground vehicles. From here we go to RC agents. RC agents is where all of your configs for the UI live, as well as uh, data storage. So we have, this is where you would put your qtable learn um, downloads. It has a test history log. This is where I logged all of the tests that I did during the build phase with test results here in the test results.txt. Um, Edge AI and RC Edge are for the larger phase two project. When we dig down into it, we get agents with the base pi. This is your basic contracts for all of your agents that come after. Q agent is your basic learning agent, with random agent being a baseline that doesn't learn. RL agent is a copy of Q agent, but a user facing version that goes into the UI. RLF agent is the same but with fractal edge exploration using the Julia set as my exploration handler. And then under runners, we have a convergence tracker, a maze runner, and a train runner. Uh, I've also have different packages for grid environments, maze environments, all of my testers per module, and then my utilities and my UI. So the UI is controlled by primarily the Streamlit app. And then if you go down into the Streamlit underscore UI, you'll find all the submodules that feed into the API. And then all of this is documented at the top or the root of the repository, starting with the README. Then you can go to architecture. This has all the top level architecture decisions and roadmap so that you can find your way through the repository quickly. And then table of contents is a GitHub facing table of contents, which isn't usable here in the development space, but on GitHub, these act as links to the individual folders and files. So if we come over here I'll run through the actual training of a agent. So I did some tests. We're gonna clear the test that I did before. We'll run a basic reinforcement learning base agent and we'll run it in an open world. Uh, the grid size is 60 by 60 with max episodes of 3,600 and max steps of 500. Simple rule of thumb for episodes is to square the grid size in order to be able to have enough episodes to properly learn the size of the grid. And then a max steps of 500 is based on experience. In testing, I found that the max steps was hitting somewhere between 350 and 400 steps, so 500 seemed like a safe max step option. Epsilon is your curiosity. If you start out at the base of point 1, you'll end up having an agent that explores the middle but doesn't explore the edges, and we want the agent to explore the entire grid for the first run. So we're going to bump up to a middle ground of 0.2 for the curiosity. And then we're going to set the target goal of row and column 50 and 50. So run the training. It takes about a minute for the training to work. And with an untrained agent, we'll get a result of something like 2,500 out of 3,600 successful runs. That was pretty close, 2,533 out of 3,600. Shows you the last runs that it did with the total reward, max number of steps that it took, and if it reached its goal. This is the Q table dense view, and then a heat map of the rewards per grid square. And then here it shows the best route that the agent took, and you'll see where it backtracked. So it came this way, backtracked, and then backtracked again, and you'll see it kind of doing that throughout the run. If we come back up here, run the training again, we should see an improvement. We did, it's 36 out of 3,600, so we got perfect scores. You'll see that the max steps is far less than the last time. Last time we were seeing 350 to 400, a little over 400 steps per episode. Now we're seeing 120 or so to 155 steps. The heat map will still be the same because we didn't actually change the grid or put any obstacles, but the best run you'll see far fewer backtracking, so it looks like we have 2 backtracks, but it looks pretty much like a straight shot. So we could do this again, but for the time's sake, I'll just go ahead and show how the Q table works. To be able to use this for future episodes or future agents, we can save it as an MPZ file, and we'll say this is run 3. And then we have our number of episodes, max steps, epsilon value, alpha value, gamma value, and grid size. So we'll save that into our database, and then next time we run this, if we set this, we could load file and bring it in for future training. That's my demonstration on my reinforcement learning algorithm. Thanks for watching.